Okay, so we are on page 56, and we are looking at normal boiling point. Way back before spring break, we were looking at vapor pressure and how it relates to boiling point. So, or how vapor pressure relates to temperature. So if you have a higher temperature, the vapor pressure will be higher because the particles have more, excuse excuse me. They have more energy, which allows them to escape from the liquid state. So you'll have more particles above the liquid. Is that ringing bells? Okay. So now normal boiling point, temperature at which a liquid boils, is when the external pressure is 1 atmosphere. Okay, so the normal boiling point of water is 100 degrees Celsius, right? And it occurs boiling occurs when the vapor pressure is equal to the atmospheric pressure. So I want you to think about that. So the vapor pressure is basically the gas pressure pushing up from the liquid because it's what was I going to say? It's the gas pressure pushing up from the liquid because the particles are escaping, yes? And the vapor pressure and the atmospheric pressure is the pressure pushing down. So when it starts to evaporate, when it starts to boil, the pressure pushing up is the same as the pressure pushing down, and that will allow them to escape. Now, because the world is big, if you had a closed system and it were boiling, it would just like go up and down in equilibrium, yes? But because the system is open, if you boil something, then it can like escape out into the atmosphere. Does that make sense? Okay, cool. So if we look at this graph here, and this is the kind of graph that you might have to read on the AP exam. So we've got our 101.3 kilopascals, which is 1 atmosphere. Okay, and along the y-axis, we have our vapor pressure. And along our x-axis, we have the temperature. So let's look at water, because water is one that we are so familiar with. Here is water here. All right. And you can see at low temperatures, the vapor pressure of water is less than the pressure of the atmosphere. So you won't get boiling. But as the temperature increases, eventually, here's our water. I should have done just this in the first place rather than scribbling all over it in the yellow. Once it hits, the vapor pressure hits 1 atmosphere, that's where it's going to start to boil. Is good? And that's really about all there is to this graph. Now, different substances have different boiling points. Yeah. Okay, so boiling occurs when vapor pressure is equal to the pressure of the atmosphere. So as you go up a mountain, what happens to the atmospheric pressure? First of all, think to yourself, what is atmospheric pressure? I just want to know what atmospheric pressure is. What is atmospheric pressure? Is Chat Rouse next door in 309? I don't think he heard me. That's okay. I don't know. Some kid came and looked in. Sorry. What is atmospheric pressure? Yeah, it's the pressure pushing down. And what is that pushing down caused by? Air. All the air from the ground all the way up to the top of the atmosphere. Yes? So as you go up a mountain, that column of air becomes smaller. Okay? So the atmospheric pressure decreases as the column of air above the ground gets smaller. So as we go up a mountain, what happens to boiling point? It decreases.
So is that not like they lower the sugar outside makes it easier?
Yeah. Sorry, what was the question? I think I missed something in there.
Pressure cooking pot.
Oh, the pressure cooking pot. The pressure cooking pot, what it does is it actually raises the temperature because
Why is it got the pressure?
Forget I said anything. Let's just go with your explanation. You won't have to answer it on the AP exam, and my brain hasn't had enough tea to think that through early in the morning. I'll think it through for you and answer you next week, okay? Ooh. All right. So, therefore, boiling point decreases as you go up a mountain. So if you travel to, say, Colorado or, Machu Picchu or someplace that's really high up that has lots of, like you're up in the mountains away from sea level, water might boil at like 98 degrees. Okay. And one of the reasons why they tell you to salt your pasta water is that very often, if you are not at sea level, your boiling point is going to be lower, so it's going to be cooking at a lower temperature. But if you add salt, it actually raises the boiling point. And we don't learn about that in AP as to why that is anymore, but it has to do with the fact that the ions disrupt the hydrogen bonds that make it easier for the, do they? Never mind, forget I said anything. Okay, there we go. All right. So if we said to you, let's do something that's actually practical. What is the boiling point of propanone? So let's go over here. Here we have propanone. What is the boiling point of propanone? Is propanone. And you read down, and it is at 55. Yes? Our convenient garbage cans in the hallway now. 55 degrees Celsius. And you could do the same thing for your water. Water is at 100. Ethanoic acid is at 120, I think, ish. What does it actually say over here? 118, and so on and so forth. Which of these substances has the strongest intermolecular forces? We have propanone, ethanol, water, and ethanoic acid. Who has the strongest intermolecular forces? Do you guys agree with her? She said ethanoic acid. Do you agree? Yes, because ethanoic acid has the highest boiling point, which means it requires the most energy to break those bonds. What kinds of intermolecular forces would you find in ethanoic acid? First of all, what would ethanoic acid look like? We have eth. So how many carbons? 2. It's an oic acid, so that means it is a carboxylic acid. Do you remember what the carboxylic acid group is? How do we make an organic acid? What do organic acids have in their formula? C O O H. Does that look familiar? Organic acids, carboxylic acids end in COOH. And the first O is a double bonded O. And the second O is an OH. And what goes on? So this is the carboxylic acid group. C double bond OOH. What goes on the other C? Next door. Something on the board. Sure. Yeah. No? Yes. Just H's, yes. Okay, so that is ethanoic acid. What kind of bonding, what kind of forces, what kind of intermolecular forces will you have if you have ethanoic acid? Hydrogen bonding, yeah? And the thing that makes this one so particularly delicious for hydrogen bonding, that makes it have such a high boiling point, is that it's always the bond between the H of one molecule and the lone pairs on the O of another molecule. And this has like super lots of lone pairs on their O's. So you could get bonding of another molecule. Let's say we had the OH here. This could hydrogen bond to here, or it could go to here, or, you know, if it was down here, it could go to here or to here. You know what I mean? There's just a lot of places where the hydrogen on another molecule could bond. Or sorry, hydrogen bond, not bond. Okay, good enough for that. Hi. So yeah, we're basically here. It's just weakest intermolecular forces, strongest intermolecular forces. What kind of intermolecular forces would we have in ethanol? Oh, and where's ethanoic acid? There we go. Are these even the same three that we had? Yeah, they are. Okay. I need to fix this up a little bit. Now, you guys don't know what propanone is, but you could guess something about propanone. What could you guess about it? About its formula? Yes? 3 carbons. Okay, so propanone, carbon, carbon, carbon. And this ending "-one" means that it is a ketone. And ketones, the ketone group looks like this. Carbon with a double bond O. Now, what does the R mean? I like to think of the R as being the rest of the molecule. It means it's more carbons, okay? Not a hydrogen, okay? So we would have, for this particular one, our ketone group would be here. And you see how there's a carbon on either side of it? Okay. And now these carbons, because there's only 3 carbons, these would have to be filled up with hydrogens. So that's how you recognize a ketone. Not that you're going to have to do that for AP, but probably in first year you'll be expected to do a little bit of organic chemistry, so it won't hurt to have learned at some point that little ketone. I always think of it because there's an O in the middle. Ketone has an O in the middle, right? There's a double bond O in the middle of the compound. Okay. Now, ethanol. Can you guys draw the formula for ethanol? Because you do know your alcohols, I think. Alcohols have what we call a hydroxyl group. What do you think hydroxyl looks like? What does it kind of sound like? Hydroxyl sounds kind of like hydroxide. Yes? So hydroxide is the ion, OH minus. Hydroxyl is OH, but bonded covalently. Yeah, not ionically. Okay. So in our ethanol, we would have to have a hydroxyl group, an O and an H, bonded covalently to the rest of the molecule. And what do we fill up the rest of the carbons with? H. Okay. And of course, water is H2O. Water, we have hydrogen bonding. Ethanol, we can have hydrogen bonding. Propanone, can we have hydrogen bonding? No, because the hydrogen is not attached to the H. So what kind of bonding, what kind of intermolecular forces would we have in propanone? Dipole. Yeah, because we've got, we're going to have a dipole moment here because oxygen is quite electronegative. Do you remember that? Okay, so we've got our dipole moment pointing towards the oxygen. So this will be slightly negative and this end will be slightly positive. Okay. Oh, and look, we have it all down here anyway. There we go. Propanone, ethanol, water, blah, 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 blah. Vapor pressure and boiling. 2 ways to get a liquid to boil. Number 1, increase the temperature in order to increase the vapor pressure. We've already looked at that. The other way is to decrease the atmospheric pressure. So actually, if you have a container and you are able to, like, say, pull up like a, what do you call those things? You know, like a hypodermic needle, except for not a needle, just a great big, like, cylinder with a, like, plunger in it. And let's say that this was closed off at the bottom. If you could pull that plunger up, you could actually make the water boil at room temperature if you made that pressure low enough. Because you're making the pressure low, so the vapor pressure will equal the pressure of the, well, in this case, it wouldn't be the pressure of the atmosphere, but it would be the pressure pushing down on that substance. I don't think they're going to ask you about that, so don't get too excited about it. Don't worry about it too much. Vapor pressure and boiling, evaporation and boiling both involve the escape of the gas molecules from the liquid, but in evaporation you don't get the formation of bubbles. In boiling you do get the bubbles since the vapor pressure can overcome the atmospheric pressure. Reducing the atmospheric pressure until it matches the vapor pressure allows the liquid to boil. We just talked about that. Well, it's 9 o'clock, so I feel like you could answer this question for homework. Is there anything else? I feel like this is just repeating what we've already said. Oh, there's some exercises here. Let's have you do page 64. Yeah? That should be, there's only 10 questions, pretty straightforward, and they're all like single word answers, so that will not take too much of your time. Thank you guys so much for being here. It's really awkward when I have to teach a lesson to myself, so I appreciate that.